When we look at series and sequences, but particularly series, which is when we add up all our terms, understanding summation notation is very helpful. So that's what we're going to take a look at before we dive into adding all those different sequences. So this is sometimes called sigma notation, and this is the symbol. And this symbol simply means to add. We're going to do a bunch of adding. So right here, generally you'll have something like this, n equals, and maybe it's a 5 right there. It doesn't matter, but these will be integers. And they'll generally be positive integers, but this bottom portion tells us where we start our summation. And up here, generally we'll have another number. In this case, I'll just put a 7. But this is going to tell me where I end my summation. Now right here, we would have a formula. So I'm going to make it a simple formula, 2n. So here's what I do. Now you don't have to make a table like I'm about to do, but I am going to go ahead and do it. So I start at 5 and I go to 7. So there we go. And if I put in 5, so that means I'm going to do 2 times 5, which gives me 10. And then the next number, so 5, then 6 is 2 times 6 is 12. And then 7 is 2 times 7, which is 14. And you've done tables like this before, like maybe you called it X and Y. But the difference here that we're going to have is we're going to add all these up. So we're going to sum these and get 36. So the answer to this is 36. So let's take a look at another summation. So where do I start? Well, I'm going to start at 3. Here's my formula, x squared, and right here is where I end. So I'm going to have 3 squared plus, because sum means add, the next number is 4, so 4 squared, plus the next number is 5, and now I'm going to end 5 squared. So that means 9 plus 16 plus 25. 25 plus 25 is 50. So this sum equals 50. Now you might be wondering, well, why would I even want to do this? I could just write 9 plus 16 plus 25, but this is most useful if you have a list of numbers that is extremely large. All right, so probably should add parentheses around this one. This time my variable is a. What the variable is doesn't matter. So I'm going to be replacing a with 2, then 3, then 4, then 5, then 6. So I'm going to have 2 times 2 minus 5. So that's my first term. Notice I just have that. Plus 2 times 3. There's my next one. Minus 5. Plus, I'll continue down here. 2 times 4 minus 5. Plus 2 times 5 minus 5. Plus, and the last one, 2 times 6 minus 5. Because this one wanted to go from 2 to 6. So this one's 4 minus 5. Well, that's negative 1 plus. This one's 6 minus 5, 1 plus. This one's 8 minus 5, 3 plus. This one is 10 minus 5, 5 plus. And this one's 12 minus 5, 7. All right, so when I add those all up, I'm going to get 15. So this equals 15. Okay, now this example is pretty tricky because I have 2 variables in here, but I'm only incrementing n. So let's give it a shot. So I'm going to replace n with 1. So I have 3 times 1, x squared minus 5x. I don't have any replacements for that. So that's going to give me 3x squared minus 5x. Now plus n is now 2. So 3 times 2. X squared minus 5x. Notice I'm not replacing x because that is not the variable that's indicated in my sigma. So I get 6x squared minus 5x plus 3 times, I'm going to go up to 3 now, x squared minus 5x, 9x squared minus 5x. And now it's a summation, so I need to add these all up. Well, negative 5 plus negative 5 plus negative 5, negative 15x. Those are all like terms. And then I have 9 plus 9 right here, 3 plus 6 plus 9. That's going to be 18x squared. I only combined my like terms. So my answer here is 18x squared minus 15x. This one involves fractions, so going from 3 to 6. So I'm going to have 2 over 3 plus 2 over 4 plus 2 over 5 plus 2 over 6. Going to need a common denominator here. I'm going to do it in pieces. I'll probably save that 5 for last. So if I look at the 3, the 4, and the 6, well, particularly the, let's see, I was thinking 36 would be good. So let's see here, 36. Yeah, I can get a 36 from all of those. Not the 5 though. So the 2/5 is going to be left out for a little while. So times 12 right here, times 9, times 6. And I'm going to add up all the ones that have to do with 36. So with the denominator of 36, so I have 24 plus 18, 3, 4, 42, and then 12, 54. So I have 54 over 36 plus 2/5. I'm hoping that I can reduce this. So 54 over 36. I'm going to cheat. 54 over 36. I can definitely divide that by 2, but maybe more. Yeah, I could divide that by 18. Well, let's do that. So this is 3/2. So 3/2 plus 2/5. Common denominator is 10. So times 5 plus times 2, 4, and I get 19 over 10. Of course, I could have just typed that all into my calculator right at the beginning. It might have popped out 1.9, but in any event, there we go. All right, last example, just to show you, it doesn't matter how complicated this gets. So we're going to go from 9 to 11. So 9 squared minus 4 times 9. That's the first one, right? Plus, now we're at 10, so 10 squared minus 4 times 10. Plus, and the next one, 11 squared minus 4 times 11. So I have 81 minus 36 plus 100 minus 40 plus 121 minus 44. And we could do this all by hand, but I'm going to choose not to. So I have 81 minus 36 plus 100 minus 40 plus 121 minus, what's the rest of it? 44. All right, 182. So hopefully you got a general idea of how to use sigma notation.